Welcome to Tomversations, a monthly chat about technology topics of interest in the enterprise with me, your host, Tom Hollingsworth, the networking nerd. This is episode 14. We're going to be talking a little bit about wireless technology again, but we're not going to be talking about Wi-Fi. We're actually going to be talking about a new technology that you might have heard of called CBRS or private LTE. Now, we all have a mobile device of some kind. It's probably a mobile phone, and that mobile phone needs to run on some kind of a provider, whether it's AT&T or Verizon or smaller providers like Cricket or Mint or Ting Mobile. But those aren't the only providers that you can have for your mobile device. And I'm not just talking about ones that are overseas or non-US providers. I'm actually talking about the fact that you can have your own LTE service in your enterprise. It's not hard, but it's not easy. But why would you want to do that? Well, let's have a conversation about that. The first thing we need to do is we need to discuss LTE. What is it? Well, when we talk about mobile technology and the protocols that govern it, we typically refer to them in the Gs. So the first generation cellular technologies, second generation, then 3G. We all remember 3G. It was the moment when cellular became something that we could actually surf the internet over instead of just simply making phone calls. Well, 3G evolved into 4G, and 4G is most commonly known as LTE, which is long-term evolution. This is kind of like the stability release for the protocols. You know, we made them a little bit faster, we made them a little bit easier to use. People can kind of rely on this as opposed to 3G, which mostly worked. Now, 5G is right around the corner. It is the fifth generation. There's a lot of things that go into 5G, and it is completely outside of the scope of this video. But let's just say that a lot of the things that we're talking about here will apply to 5G in some form, but not for a few years. All right. So most people kind of understand the basics of how LTE works. Your device has a radio in it that broadcasts at a certain frequency. That's how all wireless technologies work. And it talks to some sort of a tower somewhere. And you've probably seen these all over your town. They're gigantic. They're, dozens, if not hundreds of feet high. They have big clusters of antennas that will allow communications from a variety of mobile devices. Now, for those of you who are old enough to remember all the way back when 3G was all the rage, so that would probably be around 2008, 2009. Do you remember when you got, say, around 5,000 people in the same area at the same time and your cell phone suddenly wouldn't work? I can specifically remember being in Las Vegas for events like Cisco Live, and suddenly my cell phone wouldn't work at all, and I couldn't make calls and I couldn't do anything. But as soon as I stepped into the area where the Wi-Fi was for the conference, suddenly my phone started working again because all of the cell phones offloaded onto Wi-Fi. That's because the towers were being overloaded by the communications. And as we have evolved the technology from 3 to 4 to 5G, we have become much better at that time utilization. Devices getting on the network, saying what they need to say, and getting off. And that's why it's a whole lot easier to have towers cover a much larger area now than they did before. But there is a couple of issues with that. So Las Vegas is actually one of the biggest examples of this. You can either deploy a lot of smaller towers running at a much lower power setting to cover areas for LTE communications. That's one way to do it. Or you can build a couple of really big towers and crank the power all the way up and cover a much larger area. The problem is that your devices, there are more of them per tower, and they typically, batteries drain faster because they're having to talk more and work harder for that signal. So what if you could deploy that smaller tower package somewhere and run LTE? Well, as it turns out, that's kind of what we're talking about today. Remember how I said that devices have radios in them that communicate on certain frequencies? We know this from the Wi-Fi world. So Wi-Fi, wireless fidelity, is the protocol suite that's used in 802.11 to differentiate a specific kind of communications. Now, this is the one we're almost all familiar with because they're the wireless networks in our house and in our office. And they use terms like 802.11a or B, G, Now, when we get to 802.11n, the Wi-Fi Alliance has designated those as Wi-Fi 4, Wi-Fi 5, which is 11AC, Wi-Fi 6, which is 802.11ax, and Wi-Fi 6E, which is 802.11ax with 6 gigahertz. Now, I'm going to link up here in the iCard conversation from last season where we talked about Wi-Fi 6 and Wi-Fi 6E, and it goes into a little bit of detail between what those are about. But the important thing for you to know for this episode is that there are 3 different bands that we can use in Wi-Fi: 2.4 gigahertz, 5 gigahertz, and now in the US we can use 6 gigahertz. Well, there are other frequencies out there. So emergency radios, the ones that are used by police, fire, and medical workers, operate in a different band, 4.9 gigahertz. And LTE operates in an entirely different band as well. That's why you can have a radio in your phone that talks to the cellular provider and a Wi-Fi radio, and they don't interfere with each other. But there's also licensing involved in all of this. So for example, Wi-Fi is unlicensed. I can create any Wi-Fi device that communicates on any one of the frequencies that Wi-Fi uses, and I can just make it work. Baby monitors are a perfectly good example of this. Why? They work, and they tend to trash everything around them because they're built as cheaply as possible. On the other hand, we have LTE, which is a very licensed spectrum. You can't just jump into LTE and run your own base station. I was talking to a friend, Martin Casado, a few years ago, and he said that he had built an LTE base station in his hotel room during an event as a proof of concept. And then he realized that he had to turn the power way down on that base station. 1, because he didn't want to microwave himself. But 2, if you try to operate an LTE device above a certain power in a licensed area, the FCC will come and they will say very not nice things to you. So Martin was able to show off that he was able to kind of build his own LTE, and you can too. You just can't operate it because you're not licensed to do it. Who is licensed to do it? Verizon, AT&T, T-Mobile, Sprint. Even providers, the ones like I mentioned earlier, Cricket, Ting, and Mint Mobile, they kind of borrow that spectrum from other people. So they're not even operating their own radio towers. They're just renting them from somewhere else. Well, what if you wanted to build your own? Well, the good news is that a couple of years ago, the FCC in the US, the Federal Communications Commission, decided that they wanted to open up this capability to people to do their own private LTE. Well, what is that? Well, it's a specific band called CBRS. It's the Citizens Broadband Radio Service. And before you go out and think that this is the C.W. McCall, Convoy, Smokey and the Bandit type of CB radio, that's not it, as much as I really wish it could be, because I want to wear one of those hats. This is a 3.5 gigahertz spectrum that is lightly licensed for use by providers to provide LTE. So what does lightly licensed mean? So on the one hand, we've got Wi-Fi, which is unlicensed. It is the wild, wild west. And on the other hand, we have LTE, which is absolutely licensed. It is almost a caste system, if you will. Everyone has to follow certain rules, and you are only allowed to operate if you have those rules followed. Well, somewhere in the middle is CBRS. Lightly licensed means there are essentially 3 bands, if you will. There are the incumbents, the people who have already been here and have been operating in this band for years because they paid the money and they're allowed to do it. The mid-tier is the incoming groups that are allowed to essentially carve out a section of that spectrum for themselves. These would be new providers. These would be people who are trying to build services on this. They want protections and they're willing to pay for them. So that band is essentially off limits unless you're willing to pay. And then there will be a smaller band, which is effectively unlicensed for our purposes, which means you can turn up anything you want, but it has limits. You are not allowed to create a broadcast tower at that range that will drown out signals across, square miles or hundreds of square miles. Not that you'd be able to afford equipment that could pump out a signal over hundreds of square miles, but people are enterprising sometimes. So what does CBRS do? Effectively, it allows you to use enterprise-grade networking equipment with LTE radio equipment to provide a private LTE network. So you are essentially becoming your own mobile provider, sort of. Why would you want to use this? Think about applications that you have where you want to provide LTE coverage in a wide area. I'm sorry, not LTE coverage, Wi-Fi coverage. I have a lot of friends in the wireless industry, and one of the things that they spend a lot of time doing is site surveys. So they may be told that they need to go cover a warehouse with wireless access points, or maybe they want to provide some kind of coverage to buildings that are outside of a main structure. So they need to use things like wireless point-to-point bridges or outdoor antennas. Even something the size of, say, a stadium is ripe for this kind of application. Well, why is that? Well, Wi-Fi is really good at providing a lot of power in a very specific area. And there's a limit to the amount of power you can provide. You can only do about 100 milliwatts per access point. Anything more than that, and you're technically breaking FCC rules. So that's why you tend to see a lot of access points in an area to cover everything. Well, with LTE, the power requirements are much different and allow you to do things like use a smaller number of access points to cover a wider area, bigger warehouses. Even things like, covering outdoor areas, like say you're on a college campus and you want to cover all of the buildings with a signal. Now, why would you want to do that? Well, have you ever walked down a hallway with an iPhone or a laptop, and maybe you're on a video call, and when you get to the edge of one coverage area, your laptop kind of hiccups for a second, or your phone hiccups for a second before you get on the Wi-Fi? You've probably seen this as you're on your phone. You're like, hold on a minute, I'm walking down a hallway. Okay, you're back. That's because the access points need to hand off the signal when it reaches a certain threshold. Once it's too quiet to hear from one access point and you move to the next one, it's going to go to the next access point. But there's a handoff that has to happen. And that handoff in Wi-Fi is not the fastest thing in the world. Well, in LTE, it needs to be. Why? Well, have you ever been driving down the road at 70 miles an hour between towers and dropped a call? It's happened. It happened a lot back in the day. I mean, does anybody remember Singular Wireless? And that was kind of one of the things they did, or the Verizon guy, can you hear me now? LTE has to do very fast handoffs in order to be able to function the way that it's supposed to. So private LTE, CBRS, using the same protocol stack as LTE, just in a different band, needs to be able to perform fast handoffs. And that's one of the advantages. Here's another advantage: interference. Remember I talked about baby monitors? Well, 2.4 gigahertz, which is what we would consider to be the older traditional wireless standard, is essentially flooded with devices right now. It is low cost, and there's no barrier to entry, and there are no rules about who can jump in. So you have things like people creating IoT devices and essentially jamming that band completely full of things that are transmitting. It's almost impossible because of physics to find a place that it's uncongested. 5 gigahertz and now 6 gigahertz give us a lot more capability to have clean airspace to communicate in. But even then, they're eventually going to fill up because there are no rules to say who can and can't work in that band. LTE, on the other hand, specifically CBRS, private LTE, has rules. You are allowed to use this small spectrum, but not this one. So it's a much cleaner band. There are a lot of companies out there that are talking about using private LTE. Two of the ones that I've talked to recently are Solona and Athonet. And they are effectively building out these infrastructures that they will then sell to companies to set up their own private LTE networks. Now, it's going to also determine which devices that you can use. Obviously, most devices now have some sort of a wireless connection built in, whether it's a laptop or a tablet or a mobile phone. CBRS and private LTE require you to have some kind of an LTE radio. Well, that obviously means that it's probably going to be some kind of a cellular phone device. The good news is that the latest flagship phones from Samsung and Apple include support for CBRS. They have a radio in the 3.5 gigahertz spectrum. So if you want to deploy a private LTE solution to your employees and then pop in a SIM card that links them to Tomversations mobile and only works in the area that you're working on, say around a warehouse or a college campus, you absolutely can do that. It gives you a lot more control. It allows you to avoid paying cellular phone bills, but I really wouldn't sell it on that. Kind of like the old Vonage commercials. You may get away from paying a cell phone bill, but you're going to be paying for other things down the road. Don't think of private LTE as a replacement for Wi-Fi. We will have an upcoming podcast on the Gestalt IT on-premise IT roundtable where we specifically talk about this topic. LTE, private or otherwise, and Wi-Fi, even 5G, are going to coexist for a very long time to come because they all have different use cases. Instead of thinking that private LTE is what I'm going to use no matter what problem I have, define the problem that you have. Maybe you need to cover a stadium. Perhaps you are working in a hospital or other healthcare environment where you have critical equipment that must never be interfered with. You could provide some kind of private LTE for that equipment, or you could provide private LTE for other things that then you can ensure that your other equipment won't be interfered with. Or maybe it's something as simple as you need to cover a giant warehouse. If you, I don't know, are a large shipping company that was a former bookstore that now builds rockets and cloud computing, and you have warehouses the size of small villages, this is a great way to cover those instead of putting out 400 access points in a building and having to worry about interference and all kinds of other things. There's a lot of applications for it, and the companies that are working on this are rapidly advancing what they're capable of providing, as well as handset and mobile providers who are continually building the technology into their devices so that on the day you decide you want to invest in this and deploy it, you're ready to go without any extra effort. Do the research, find out what works best for you, and don't get caught up in the hype of getting rid of my mobile provider or, well, 5G is going to change everything, because both of those statements are absolutely untrue depending on the use case that you have. Well, that should just about do it for this episode of Tomversations. Thank you very much for tuning in. I hope that you found our journey through private LTE and CBRS to be enlightening. And I want to thank a lot of you for the great comments that you've been leaving on these videos, talking about how I'm helping you digest certain topics and understand technology a little bit better. That's really what these conversations are about, is taking complex topics and breaking them down so they're a little bit easier to understand and hopefully teaching you something along the way. I'm always on the lookout for great new topics. So if you want to leave a comment about something you are curious about in the enterprise IT space, I'll be happy to cover it. We publish these episodes monthly on our website at gestaltit.com. You can also check out some more great content that we're creating there. I mentioned the on-premise IT roundtable, of which I am a frequent host. We also have things like the Checksum series, unboxing videos, utilizing AI podcast run by my friend and boss, Stephen Foskett. If you have any discussions about the practical applications of AI, you're definitely going to want to tune in there. You can also head over to our YouTube channel. It's youtube.com/GestaltIT video, where you can see all the videos that we do here, along with some of the other great content that we create, like technical interviews and spotlights and showcases, more content that comes to you from some of the providers of the solutions that we talk about here on Tomversations. I'm going to go ahead and wrap up this episode, though, but I look forward to seeing you all next month for another great conversation.